Hey guys, in mathematics, sometimes we are faced with large numbers, like this one here, 6 with 9 zeros. What number is that? 6 billion. 6 billion. Can you imagine writing a number that large? At times we have to write it. But we mathematicians, once again, we like to make things simple. So 6 billion, 6 with 9 zeros, or any number for that matter of fact, can be written in what we call standard notation or scientific notation. Scientific notation, standard notation, they mean the same thing. Sometimes we're going to be asked to write numbers this large, or even smaller, or even larger. In scientific notation, how do we do that? Basically, looking at the theory first before we do some practical examples. 6 billion has a 6 and 9 zeros. How do we write that in scientific notation? We look for the decimal point. Where is the decimal point in 6 billion? The decimal point is right at the end, at the last zero. 6 billion point. What do we do with that point? We grab the point and we move the point to make a number between 1 and 10. Between 1 and 10. So we jump and we move the point, jump over every zero until we get to a number between 1 and 10. In here, we're going to put it just after the 6. Just after the 6. So it becomes 6.0. 6.0. 6.0 is a number between 1 and 10. Now, what do? 6 times how many jumps? We jumped to the left. How many times? We jumped 9 times. Because we jumped 9 times, 6 times 10 to the power of 9. That is scientific notation. We made the 6 billion into a smaller number. 6 times 10 to the power of 9. Now let's do some practical examples for you to understand it much better. We have 359. 359. 359, we'd like to write it in scientific notation. We look for the decimal point. Where is the decimal point? Well, we can't really see it, but we know it's right at the end. The decimal point is here. 359. Now what do? We want to make a number between 1 and 10. Make this number into a number between 1 and 10. We grab the point and we jump. If we put it here, we're going to get 35.9. Is that a number between 1 and 10? No, it's not. So we've got to go back again. If we put it here between the 3 and the 5, it becomes 3.59. Is 3.59 a number between 1 and 10? Yes, it is. So we're going to put it right there. 3.59 times 10 to the power of how many jumps? How many jumps did we do? 1, 2 to the power of 2. 3.59 times 10 to the power of 2. That is scientific notation. This number is exactly the same as that. It's just written in scientific notation. Let us do another one. 15,300. We want to write it in scientific notation. First thing, we look for the decimal point. Where is it? It's right at the end. 15,300 point. We move the point and we want to make a number between 1 and 10. So we jump. 1, 2, 3, 4. We're going to put it between 1 and the 5 because it will become 1.5, a number between 1 and 10. 1.53 times, always we write 10 times 10 to the power of how many jumps? 1, 2, 3, 4. 1.53 times 10 to the power of 4 is exactly the same as 15,300. So remember, we look for the decimal point, we jump, we move it back to make a number between 1 and 10. We can't put it here because that will be 15.3. We can't put it here because that will be 0.15. That's smaller than 1. So we must put it right there between 1 and 5 to make a number between 1 and 10. 1 and 10. 1.53 is a number between 1 and 10. So 1.53 times 10 to the power of 4. Why 4? Because we moved the point 4 times. Let's do another one. We have 2,450,000, another large number. We would like to write it in scientific notation. We look for our point, it's right at the end. 2,450,000 point. We want to move it back. We want to make a number between 1 and 10. 1, 2, 3, 4, 5, 6. We're going to put it between the 2 and the 4 because it will become 2.45, a number between 1 and 10. 2.45 is a number between 1 and 10. 2.45 times what? Times 10 to the power of how many jumps? 1, 2, 3, 4, 5, 6 to the power of 6. 2.45 times 10 to the power of 6. That's how simple it is. We always look to make a number between 1 and 10. Let's do some more examples. Now what if we are given a question like this one? It's already in scientific notation and we want to write it in our basic numeral as a normal number. What do? We go back and we do the opposite. Let's see how. 1.35 times 10 to the power of 3. 10 to the power of 3. That means we got to jump, we got to grab the point and move it to the right 3 times. We're moving it 3 times because 10 to the power of 3. So in reality, 1.35, we grab the point and we're going to move it 3 times to the right. 1, 2, 3. 1, 3, 5. We are jumping over nothing, so we put 0 and we put our point. Move once, move twice, move 3 times. We're going to put our point right there. 1350 point. 1350.0 or just 1350. We move to the right 3 times because power of 3. 2.025 times 10 to the power of 2. 10 to the power of 2. We're going to jump how many times? 2 times. We're going to grab our point and we're going to jump to the right twice. 1, 2. 2, 0, 2. Now we're going to put our point between the 2 and the 5. Our answer is 202.5. So 2.025 times 10 to the power of 2 is exactly the same as 202.5. We grab our point and we move to the right twice because it's 10 to the power of 2. Next one. 8.54 times 10 to the power of 5. 10 to the power of 5. What does that mean? We're going to grab our point and we're going to jump to the right 5 times. 8.54. We grab our point, we jump 5 times to the right. 1, 2, 3, 4, 5. 8, 5, 4. And we're jumping over a 0, a 0, and a 0. So our answer is 854,000. 854,000.0, which is just 854,000. It is that simple. It's easy. Follow the rules. We are jumping over numbers. Here we jumped 5 times because 10 to the power of 5. Here we jumped 3 times, 10 to the power of 3. 1, 2, 3. And here we jumped twice because 10 to the power of 2. We jumped to the right. Now let's do some more examples that involve very small numbers. We looked at large numbers and we changed them and we wrote them in scientific notation. What if we have numbers similar to these, where they are small numbers, very small in fact, they are much less than 1 whole, 0.0034, and here we have 0.00053. How do we write these numbers in scientific notation? Watch this. We're going to grab our point once again. We're going to move the point, this time to the right. We're going to move to the right to make a number again between 1 and 10. Between 1 and 10. We grab our point and we're going to move once, twice, 3 times. We're going to put it between the 3 and the 4. Why between the 3 and the 4? It's going to become 3.4. It's a number between 1 and 10. If we put it right there between the 0 and the 3, it will be 0.3. That's less than 1. And if we had put it here, it will be 34 point, which is larger than 10. 34 is bigger than 10. We want a number between 1 and 10. 3.4 is a number between 1 and 10. Times 10 to the power of how many jumps? 1, 2, 3 jumps. But this time, because we jump to the right, we must put a negative. We must put a negative. Very important that you don't forget that. 3.4 times 10 to the negative 3. This one is very similar. 0.00053. Once again, we want a number between 1 and 10. We grab our point and we jump. 1, 2, 3, 4. We're going to put it between the 5 and the 3 to make a number between 1 and 10. It will be 5.3. So our point's going to go right there. 5.3 times 10. How many jumps? 1, 2, 3, 4. And it's negative 4 because we jumped to the right. 5.3 times 10 to the negative 4. So whenever you see a negative, you know straight away, when you work it out, you know you're going to get a small number, very small, like this one. Let's do 2 more examples. Wow, look how small that is. Very small. We're going to write it in scientific notation. How are we going to write it? Exactly the same method. We're going to grab our point and we're going to move it to make a number between 1 and 10. 1, 2, 3, 4, 5, 6, 7. We're going to put our point between 6 and 2. It's going to become 6.28, a number between 1 and 10. 6.28 is a number between 1 and 10, times 10 to the power of how many jumps? 1, 2, 3, 4, 5, 6, 7 jumps. And we know we jump to the right, we're going to put a negative. 6.28 times 10 to the negative 7. Very small number. Next, we have 0.00000000037. We want to write it in scientific notation. Follow this one and see if you can do it as well. We grab our point and we're going to move. 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going to put it between the 3 and the 7 to make a number between 1 and 10. 3.7. Now times 10. Always times 10 to the power of negative 9. We jump 9 times to the right. That means it's going to be negative 9. 3.7 times 10 to the negative 9. This is how we write numbers, large or small, in scientific notation. We grab our point and we put it where we can make a number between 1 and 10, and then times by 10 to the power of how many jumps. It is very easy. understand the concept, and you won't make any mistakes. Now we're going to write these in basic numeral. We're going to change and go back the other way. 3.5 times 10 to the power of negative 3. So how are we going to write that? 3.5 times 10 to the power of negative 3. Negative meaning we're going to go back the other way. Our 3.5 is there. And we're going to go back now to the left. How many times? 3 times. 1, 2, 3. 0. Point. There's going to be a 0 there and another 0 there. And then the 3 and the 5. 0.0035. We grab our point and we go back to the left 3 times. Negative 3, we're going back 3 times. 0.0035. The point was initially between the 3 and the 5, and we go back 3 times. 1, 2, and 3. 0.0035. Next, 2.95 times 10 to the power of negative 2. What are we going to do? We're going to jump and go back to the left twice. So we have 2.95. We're going to grab our point and move twice to the left. 1, 2. So it's going to go right there. So 0. We have our 0 right there. 0.0295. We jump over the 2 and jump over nothing, which means we're jumping over 0. We put our point. 0.0295. That is our answer. This is the same as 2.95 times 10 to the power of negative 2. Let's do our last one. Last example now. 5.47 times 10 to the power of negative 5. We're going to move to the left. How many times? 5 times. We're going to grab our point. And we're going to move to the left 5 times. 1, 2, 3, 4, 5. Our point's going to go right there. So 0 point. We're going to have 1 0, 2 zeros, 3 zeros, 4 zeros. And then 5, 4, 7. 0.0000547. That is the basic numeral, the basic answer for 5.47 times 10 to the negative 5. See how we have to move the point depending on the power of the 10. In this case here we moved 5 times because it was power of 5. In this case negative 5, and here negative 3, and here negative 2. Make sure we watch out for that one. We're always making a number between 1 and 10.